So Google has just launched a research paper. It's called Nested Learning, the illusion of deep learning architecture. This video is a detailed analysis of what actually this paper represents. So if you see, I think most of you are familiar with another research paper called Attention is All You Need, how it has changed the course of AI. Similarly, if you look at this paper, I think it might dictate or decide how another decade of AI might look like. Because if you see most of the LLMs, they forget things. They're not continuous learners. Once you deploy, that's it. They become static. And also even for a very specific or like even very minor change they has to invest a lot of money into it, and it's very difficult for companies to keep up with these changes. And also if you fine tune a model, it might affect the previous skills of this model, right? So if if you look at it, what are the problems that they're trying to solve? In this paper, they're mainly targeting these three key points. One is memorize fact short term, build long term understanding, continuous new learning. If you see, let me explain you with a small analogy that we have. So usually if you look at it, imagine you are studying for an exam. What you can do is either you can memorize facts short term, like preparing just before the exam. So the night before the exam, usually most of the engineers do the same thing. I also did the same thing. Or what you can do is build long-term understanding, like truly learning concepts from the like 1 or 2 months before that. You try to understand whatever they have taught you in the classes, all these things, right? And another is continuous learning without forgetting old. So current AI models, including those based on transformers and architecture, from what we have learned from Attention All You Need is, are really good at one. They learn very quickly and they memorize short term. This paper introduced something called nested learning, where it considers the neural network is a single system with lot of learners. It's like a single continuous learning process where hierarchically there are a lot of small learners, which you might call as a team of learners, which will continuously learn so that they won't forget things. So how, if you can connect the relation between this paper and the previous paper, that is attention is all you need. So attention is all you need introduced the transformer architecture, which has three key components such as query, key and value metrics for attention, feed forward learning networks for processing, training via back propagation using optimizations like Adam. The problem, once the training ends, transformers become static. They can't really learn new things without expensive training. So they only adapt within immediate context. That is short-term memory. So that's where these nested learning comes in. Nested learning, what they do is the authors propose viewing neural networks as not as a single learning system, but as a multiple nested optimization problem. As I mentioned, if I have to put it clearly, it's like a human brain where the neural networks has a lot of small learners which will learn at a different pace, and overall it keeps learning. It never stops. Similarly, attention mechanism. So in the attention, they have already cleared it, where it's like figuring out it refers to the cat, something like that, right? It's like if you given a sentence like the cat sat on the mat because it was tired, the assistant figures it out it as to the cat, not on the mat, because it has the query key that we have already discussed, right? And they feed forward. That is the problem with them. It's like very short-term memory. It can remember till the training happens. After that, it keeps forgetting. So what happens with nested learning is if you learn to ride a bike, you're actually learning at different speeds. One is super fast, adjustments, all these things, right? So another is fast, steering corrections, and another is medium, understanding how to pedal smoothly. Slow, like it will take hours and day, is building muscle memory, right? You won't build muscle memory at a time, slowly. So if you remember this process, riding a bicycle, it will you're learning certain things at certain speed. You have fast, you're learning something fast as balancing, how to keep the balance, something super fast like steering corrections, something very medium, some things you learn very slow. That is building muscle memory. So nested learning says AI should work the same way. Different parts of AI should learn at different speeds. so that it can adapt over time and it can adjust to the new word learning patterns and all these things. Remembers from recent charts. So what happens is over a time it improves, it learns how to remember things, and it keeps learning. It's not like one time it's done, it's going to see. So in this paper, there are a lot of key important points that we can see. But what I feel is important thing is there is a concept called optimizers are actually memory systems. One discovery is that this is like discovering you're not taking system is actually a learning process. So what do you mean by not taking learning system? Simple example. Imagine you're learning to throw darts, right? One bad method is throw dart, adjust exactly based on what it's landed, repeat. Good method, what we are suggesting is throw a dart, remember your last few adjustments, what you have done, make a smart adjustment based on the patterns. Like if you're going out of what do you call the target area, you remember where you're going, why you're going, all these things, right? So similarly, when you do this, this is a correct way of learning, because what are all the previous mistakes that you've done are going to help you adjust your patterns. The key important over here is remembering your last adjustments. Okay, that's how you learn. Another is, let's say attention is also needed in learning. So how do I put it? Something like, let's say a librarian is organizing books, right? If a librarian is organizing books, traditional view of how, if you go to the representations of all you need is attention article, someone asks, find me book about, let's say, space. Librarian will go to the catalog, search for the keywords, then return the whatever results it will get, he will show it to you. What happens in nested learning is the librarian's search system is constantly learning which books are popular and reorganizing the catalog, right? So if he's learning and if he's going through this, what happens is he understand what to give. It's not like whether whatever the keywords that are getting might not be the correct, what do you call, correct books that the user might need, right? Which was the case earlier in attention all you need. But in this, if the librarian starts learning, constantly learning about new books, what are the famous books that are coming in that space, he can give a better results. Another is we need multiple memory systems. Think about how, let's say, how we remember things from yesterday. Let's say immediate memory is the exact words someone just said, right? Working memory, you do all the lists today. Recent memory, what you did this week. Long-term memory is your childhood, right? If you look at how we remember things, is the short-term memory, long-term memory. If you categorize it, the last words said by someone to you are like immediate words. If I coming to office, just before entering the office, someone might have spoke with me. That is the short immediate memory that I have. Like yesterday or something like that, or today's working memory. Like today I have to do these things. That is working memory. So if you compare this, transformers have only two levels. One is what are you reading now? That is attention, and everything from the training that has been done long back. So these are the only memories that we have. But there is a new model called Hope, which was mentioned in this article. There has many levels like current word, current sentence, current paragraph, recent conversation, long-term knowledge. Each level updating at its own. So you're understanding, right? They're differentiating the memory into multiple layers, and layer has been each layer has its own speed of learning things or something like that, right? So that's what they're doing. At the end of the day, they're saying that if you can, because what happens is with this attention, yes, attention is good. It has gotten us lot of changes in the system, but the problem is it won't scale after some time. What many people are saying that this is in 2020, it was a research era. From 2020 to 25, it's a scaling era. After that, we might go back to the research era, because with this attention and all these things, it is going there is a cap there is a cap on the scaling part with this knowledge that we have. So we need systems to learn which are continuously learning. It's not like one static LLMs. Static LLMs are, yes, they are useful. I'm not saying they're not useful, but there is a limit for that. Now we need systems which will learn uh, which will learn on their own all the mistakes that they learn. And it's the learning process is a continuous one. So it is the next thing that is going to affect. This is what a basic is. If you want, you can go through this paper. This paper is called Nested Learning, the illusion of deep learning architecture.